Hello and welcome back. Today we are going to analyze two-dimensional trusses using joint method. Before we jump to the topic, trusses are usually used when we are going to cover longer spans which are unable to be covered by concrete due to the structural analysis limitations. For example, assume that you have a span of 50 meters. If you're going to cover that with concrete beams or any other type concrete structural elements, it will be heavier, and in some cases it will not be feasible. If you go to the big stadiums or maybe halls, the structures are covered using two-dimensional and three-dimensional trusses. In this video, we are going to analyze a truss using joint method. Basically, if you're going to analyze trusses in structural analysis, there are two methods. One is the joint method, another is the section method. In this video specifically, we will talk about truss analysis using joint method. In here, as you can see, we have a 2D truss which is used for roofing of a hall. The loadings are given. We have the angles between the elements of the truss. We have a support at point A, which is a pen support, and we have a support at point D, which is a roller support. These are the usual types of supports used for trusses. The elements in the truss either go in compression or in tension. They never go into bending, but the truss as a whole, it might go into bending. So let's get started and let's analyze this truss and find the amount of forces in each of the members and find whether those forces are in compression or tension. So the first thing that we are going to do in here is to find the reactions at joint A and joint D. These could be found using the equations of equilibrium, since this is a statically determinate structure. On the other hand, if you see, this is a symmetrical truss, so the loads for that purpose will be divided equally in this support and this support. So the total force acting on the truss will be 8 kilonewton, out of which 4 kilonewton will go to support A and 4 kilonewton will go to support D. Once this is done, next thing is to go joint by joint and find the amount of forces in each of the members and the type of the force, that whether the member is under compression or tension. So let's start from joint A. In joint A, we had a reaction of 4 kilonewton in here. Next thing in here is that we don't know yet whether the forces on the members are going to act in compression or in tension, so we will assume they will act in tension. For that purpose, the direction of these forces taken out of the joint, which means that the forces are acting in tension. So in here we have the member AB and the member AG. So for this joint, we will use the equations of equilibrium and we will write down the summation of forces in the x direction are going to be 0. We will assume that this direction will be positive. So in here, we will have the force AB and the component of force AG, which is the force AG itself times cosine of 30 degrees. So the summation of both these forces will be equal to 0. From here, we can write down an equation where the force in member AB will be equal to minus 0.87 times the force in member AG. Next thing is we are going to find the summation of forces in y direction. In here, we can write down the summation of forces in y direction. If we assume the upward positive, it will be 0. In here, we have a 4 kilonewton. Besides that, we have a component of force AG in the positive y direction, which will be force AG times sine of 30 degrees. From here, we can find the force in member AG to be minus 8 kilonewton. What this means is that the direction that we initially assumed is in the opposite direction of the actual acting of the force, which means that the force in member AG is acting in this direction. Or in other words, this member will go under compression. So from here, we can replace this value in here and find the value in member AB to be 6.93 kilonewton. Since this is positive, we will be sure that the direction that we assumed is okay and the member is under tension. On joint G in here, we have a 3 kN force acting downwards on joint G. We had an 8 kN compressive force from the previous member of joint G. In here, we want to find the values for the forces in member GF and member GB. For ease in our work, we will introduce new x and y axis in here. So this will be our x-axis and this will be our y-axis. The summation of forces acting in the x direction will be 0. From here, we can find that the force in member GF will be minus times 0.5 force in member GB plus 6.5 kN. The summation of forces in the y direction will be 0 again. From here, we will find the value of force in member GB to be minus 3 kN. In other words, we assume that this member is in tension, but our analysis indicates that this member is in compression. If we replace this value in here, we will find that the value of force in member GF will be minus 5 kN. In other words, we assume that this will be in tension. However, actually this member is in compression. And last but not the least, we are going to analyze the joint B and find the forces which are unknown yet, which is the force in member BF and force in member BC. Once we find these forces, since the truss is symmetrical, the forces on the other symmetry of the truss will be the same. Again, we will use the same equilibrium equations. First of all, we will find the values in the y direction. From here, we can find the value in member BF to be 3 kN. Since this value is positive, our assumed direction is okay and the member will be in tension. The same applies in the x direction. In here, we'll find the value of member BC to be 3.46 kN, and since this value is positive, our assumed direction is okay, and this member will be in tension as well. As I mentioned earlier, this part of the truss is symmetrical to this part, and the forces are symmetrical, so the values of the forces and the members will be the same. Once you obtain the values for the loads, which are both in compression and tension, then you can go and proceed to designing the structure. If you found the video informative and helpful, support us by subscribing to the YouTube channel and following us on Instagram and LinkedIn. Thank you very much for watching.